Okay, now I'll talk about the continuous random variables and normal distributions and z-scores. Normal distributions and z-scores. Normal distributions is the most common continuous probability distribution. It's also called Gaussian distribution, normal curve, and bell curve. And it is symmetrical and unimodal, which means that it has only one peak, and the total area under the curve equals to 1, which means that 100% of data is under the curve. The normal distribution is defined by two parameters, which means that it is affected by the mean and standard deviation. And it follows the empirical rule, which means that about 68% of data falls within minus or plus one standard deviation of the mean. About 95% of data falls within positive or negative two standard deviation of the mean. About 99.7% of data falls within positive or negative three standard deviation of the mean. And the picture on the right shows the detailed distribution, and it is really direct and clear. About z-scores, it tells us how many standard deviations the value is from the mean. Value of if the z-score value is positive, that means that the value is above the mean. And if the z-score value is negative, that means that the value is below the mean. And the formula is the z equals to x minus the mean divided by the standard deviation. And we can use the z-score table when we know the z-score value to check the probability if the value is given. Like this question, we have the weights of watermelon at a supermarket are normally distributed with a mean of 4 kilogram and a standard deviation of 0.5 kilogram. And what is the probability of randomly selecting watermelon weighs more than 5 kilograms? And firstly, we can figure out the z value, and the z equals to 5 minus 4 divided by 0.5. And since we have been given the x value, mean, and the standard deviation, so the z equals to 2, and we can look up the z value. We have given that z equals to 2, so we can get the probability if z is smaller than 2, it is 0.9772. So since we need to get the probability that the weight is more than 5 kilograms, so we need to use 1 minus 0.9772, which is 0.0228.
Today, I'm going to talk about continuous random variable and the density curve. First, I'll introduce few concepts. When we say some data is continuous, it means they can assume any value within a range. Then, the steps of transforming raw data into a continuous distribution. We will take raw data and put the data point into intervals. Then, we will calculate the relative frequency of the data point. Third, we will connect the midpoint of the relative frequency plot. For the shapes of distributions, we have unimodal, bimodal, and multimodal. And the symmetry of distributions, we will have positively skewed or negatively skewed. Then, for the outliers, the definition of that is data point that stand away from the body of distribution. For the question is below our student's score on a data management examination. Draw a probability distribution for this variable, then add a frequency polygon to this histogram. First, we will calculate few intervals. So here is the interval we have. Then we will calculate the midpoint for each intervals, and we will find the frequency from the table here, and we will use the frequency divided by the total number. We will get the relative frequency. Then we will label the x and the y axis for this graph. The x-axis is score and the y-axis is relative frequency. Then we can say the blue part is the probability distribution for this variable. Also, we know as the density curves. Then we connect all the midpoint. We will get the polygon for this graph. So that's all. Thank you.